Okay, so far we've been having K constants, K equilibrium constants, okay? And those are for A and B, put your phone away, Craig, making C and D in an equilibrium. But there are certain situations where we have special values that aren't just for any other kind of reaction. So we have Kw, that's only for water, Ka, that's only for acids, and Kb, which is only for bases, okay? Now by acids and bases, I don't mean an acid in a reaction. I mean an acid in solution and a base in solution. If I mean an acid and base reacting together, I now go back to KEQ, the stuff we've just done. Okay, so there's KEQ, which is about a reaction, and then there's KW, which is for water by itself, Ka, which is for an acid by itself, and Kb, which is for a base by itself. Okay, you need to know that so that you know how to begin the question, what pathway to travel down when you've read the question. So Kw in water, a tiny, like I mean 2 in a billion molecules dissociated to H plus or H3O plus and OH minus. Okay, so the equilibrium lies in which direction here? Towards the reactants, or towards the left, or you could say the percent yield would be less than 50%. Ionization would be less than 50%. Okay, so Kw would be, well, the same as like we were figuring out before, products over reactants, H3O plus and OH minuses, oops, hello, H3O plus and OH minuses, products and reactants being the water, except for, and I've got it squared here because I've got H3O plus, so I needed a second water. Except for we don't include pure liquids, right? We include aqueous and gases, but not liquids and solids, unless it's all liquid and all solid. Remember that from your quiz that you handed in? I hope you remember that on your quiz that you handed in. Yes? Did you? Chris? Good. So that's good canceling out, and so you just end up with Kw equals concentration of hydrogen and concentration of OH minus, and Kw is this value at SATP. Okay, standard ambient temperature and pressure, which is, anybody remember the degrees Celsius? 25 degrees Celsius. Remember how K constants have to do with the temperature? Okay, so that value equals those concentrations multiplied by each other. Oh, have you not seen this formula? Have you not seen that in Chem 20? You saw it on the Chem 20 review sheet. Only we probably put H plus there instead of H3O plus, but it's the same thing, right? That's where that number comes from. It's the Kw. 1 times 10 to the power of negative 14. So all those pHs and all those OH minus formulas that you had in Chem 20 were all around SATP, all about 25 degrees Celsius. Guess what happens when we change temperature? It changes to Kw. If I change the Kw, it's going to change these concentrations. If I change this concentration, it changes the pH. And that's where we can get the pH scale to go above 14 or below 0 even, if I change the temperature. Okay, so everything you learned in junior high was true because you were talking about everything at room temperature. At room temperature, the pH of lemon juice is whatever. At room temperature, the pH of toothpaste is whatever. So it was fine. We just used the scale of 1 to 14, no problem. But now we understand Kw and that temperature affects it. Remember, exothermic direction, endothermic direction, right? And so now we can change the Kw and we can change the concentration and we can change that. So sometimes you might end up with a pH that's -2 in your calculation. As long as it's not at 25 degrees Celsius, that's okay. All right? Right, so, and if we've got time, we play with that a lot because it's kind of fun to see like how the temperature changes pH of the same thing. But that's all. We don't have time. Maybe we'll do it after the exam. And in neutral solutions, you must remember that those two concentrations equal each other. That is, by definition, neutral solution. Okay, so if the question says blah, 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 neutral, write that down somewhere, because it's gonna be important. Like, that's gonna be part of the calculation. Okay, so if those equal each other, then those both equal x, and then that equals that, and then in an acid, the H plus concentration is greater than that, the OH minus concentration must be less. And in a base, that must be less, and that must be greater. Okay? Yes?
First, given the KW constant, I'm confused what we're solving.
Well, for example, what if I gave you the pH of lemon juice? Okay?
Okay.
And I asked you for the OH minus concentration.
Okay.
You would use this formula to solve for it,
Okay.
just like we would have in Chem 20.
Okay.
Only I'm telling you this number comes from the KW value. Okay? And I could also ask you, at 25 degrees Celsius, no, I mean at 250 degrees Celsius, the KW is now, I have no idea, 1.8 times 10 to the power negative 14. What is the pH of the lemon juice now? So you would find this, and then you would find pH. Okay? All right. Ka is about acid ionization. Remember acid by itself? Weak acids exist in equilibrium, strong acids do not. So strong acids don't have a Ka value, which is why it just says very large on your data booklet. Because it is. It's very, 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 very large. And so we tend to not talk about Ka when we talk about strong acids, only weak acids. So you always put the weak acid with water. Okay, so in your Ka, it's always weak acid plus water. Always. And the proton transfer. Did you write this down when we were doing our organic unit? Do you remember that from organic?
Which part's
The ethanoic acid in water?
Yes.
Right? Dissociates into that and that. Remember? Okay, so you've seen this now about 3 or 4 times. In fact, I even asked you to write a KEQ for this expression at the beginning of this unit. Okay? Although now I'm telling you, we actually should have called it Ka. But it's the same jazz. As long as you remember to put your weak acid with water, it's the same as it was before. That's the important bit to remember. Weak acid plus water. So all those Ka values on your data booklet are all about that acid plus water goes to that. So the Ka values in your data booklet are based on that reaction, that equation. Okay? And there's the expression for this one in particular. And then here's the general, which they like you to know and like to ask you about. So in general, all weak acids would react with water. And that proton be transferred from there to there, so you end up with H3O and the A minus. And so in general, that's your products of your reactants.
What's the HA mean again?
Like HCl, HBr,
Okay.
CH3OH. So they use A for acid.
Okay.
Yeah. The larger the Ka value, the more this is bigger than this. The top is bigger than this if it's a larger Ka value. So the more products, and therefore it's a stronger acid. The larger the Ka value, the stronger the acid. And the higher up in the data booklet it is. Okay? I know I'm going very fast. Are you still with me? Girls in the back, you okay? Yeah? And for strong acids, you will like to jump into this equation. But I'm going to say, no, you don't need that whole big thing, ice table, blah, 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 because this. If you've got a 1 mole per liter of strong acid, you've got a 1 mole per liter of H+, just like Chem 20. Nothing new, no ice table needed. For strong acids, just like Chem 20. Okay? All right, and then KB is kind of the same thing as KA, really. We take our base, which it's easier for us to think of the base as the A minus. And we see what is that in water. And the water transfers its proton over here. We end up getting our HA back, not back, pardon me. We end up getting our HA and our OH minus. And that's why it's basic, because it has the OH minus there. Okay. For example, CN minus was one we saw yesterday. So the KB for CN minus would be the CN minus and water, giving you HCN and OH minus. And therefore the general expression for KB is that. Everybody okay with that? If you are finding your Ka on the page above, there, at 25 degrees Celsius, if they want you to solve it, it'll be at 500 degrees Celsius or something like that. It's in the data book, right? You've got a whole table of Ka values for a whole bunch of weak acids, and it's all about the weak acid in water. Everybody fine with that? Yeah. But there aren't any Kb values. And they might ask you for a Kb value. So you find the Kb value by doing this fancy-dancy equation. That one. Ka times Kb equals Kw. And at 25 degrees Celsius, Kw is?
1 times 10 to the power
Good. 1 times 10 to the power of negative 14. And your Ka value is in your data booklet. And so therefore you just plug in the number, you can find Kb.
So they're not going to ask you to find it if it's on at 25?
They could, but it would be like a long question. Like ice table, da 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 da, plug it in, get your Ka value, then do this for your Kb. Okay? Okay? Right, so write an expression and value for Kb for NH3. So I've already started it for you. It's your NH3 in water. So the proton is transferred from the water to our base that we're talking about. Okay, and we get NH4 plus and OH minus. So write the expression for Kb. What's the expression for Kb? Just like you did on question 1 of your quiz.
So it'd be like Kb.
No.
concentration of NH4
Concentration of your NH4 plus
times the concentration of OH minus
times the concentration of the OH minus
over the concentration of NH3 times the concentration of water.
No.
Oh.
Right. And they will put water in one of the multiple choice answers, just so you know. Everybody okay with that? So that's the expression. What's the value? What is that? What's the number of Kb? What does that equal?
Kw divided by Ka.
Kw divided by Ka. And Kw is? Oh. Oh, really? Really? And your Ka value is? Sorry, pardon me, Heaven?
5.6 times 10 to the negative 10.
How did you know that?
Where do you find it?
Find it in your data booklet. Find your NH4 and NH3 combo. Because the conjugate acid excuse me, has a Ka value. Thank you. And did you find it, Jillian? Yeah. Is it what 5.6 times 10 to the power of negative 10? Yeah. I think it's 10 is ready. And then tappity tap in your calculator. What do you get?
1.8 times 10 to the negative 5.
Yes.
If there's numbers in, like, numbers in front, do you use those in the square?
If there are numbers in the front. Oh yes. Yes. But in an acid and a base, it's that plus water.
Junior class change.
In an acid and a base equilibrium. Okay, so remember how this is the second chapter of this unit, acid-base equilibrium? The first chapter was like H2 and I2 reacting together to give you HI. It's not an acid-base reaction, there's no transfer of proton. Here we're transferring a proton. How many protons do we transfer at a time? One. So your relationship's always going to be 1 to 1 to 1 to 1. For Ka, Kb, Kw, and any Keq that has to do with an acid-base transfer. Okay? However, reminding ourselves about last chapter, if you did have H2 plus I2 giving you HI, you'd have a big 2 in front of that HI, and yet you would square that one. Okay? Yes?
So that you use the conjugate acid for that K value
Yes.
in every situation?
Yes. Never say every, but yes. Yeah.
For the units, is it just going to be moles per liter, but instead of one moles per liter left? Or?
Okay, so the units for Kb would be moles per liter because, yes, correct. Yep. Fine.
Essentially, these are like all the same as K and Q. It's just like breaking it down to.
Right. So here's the danger. The danger is you look at that and go, it's the same. Not going to think about it. Here's the bad thing. Okay? They will give you a reaction like this. Can I scroll down a page? Can I get a blank page somewhere? Oh, no, you don't know what I'll do this. They will give you an equation like this. Here's an acid, HC, no, I can't use HCl. I'm going to use, CH3COOH and sodium hydroxide, directly out of an example that we've done in organic. What are our products? Na plus, CH3COO minus, and H2O. Everybody okay with that? Okay, so lovely organic question there. Here's the equilibrium part from unit 4. In this reaction, write the Ka expression and value for the acetic acid. And you right away, write the expression, right? So you right away launch into Na plus and CH3COO minus and water's not included, divided by CH3COOH and NaOH. Do you see how a person would do that? Because on your quiz, question 1, that was it. No, wait a minute. That is the answer to KEQ. This equilibrium reaction. That's the answer to KEQ. What's the answer to Ka, which was the question? Remember, it's about your acid in water and the proton transfer, and then therefore, so this doesn't even matter for Ka. So you can write it all out, or you can know the general expression, and so your Ka is going to be CH3COO minus times H3O plus all over the HA, CH3COOH. That's the answer to the Ka. You see that? One question, two ways. they could ask you for the KEQ. That's what we did on our quiz, question 1. Or they could ask us for our KA, and that's what we're learning today for the acidness there. Do you see the slight difference there? Okay. And now the toast we can solve. I think that's about it. Okay, so the next bit are questions to practice your constants, to practice your reactions, and at the very bottom, please do not do question 8 until we're going to do that one as a group, because there's something I haven't taught you yet that I'm going to teach you by doing that question. Okay? 8 at the bottom, the very last question. The one I've written in person. Okay? You may start. You've got 25 minutes, and you're going to finish this for homework.